explanation, formulas, graphical representation, and gas laws application into our real life situations. So coming to the gas laws, the first gas law is Boyle's law. So gas laws explain the relation between measurable properties. So what are measurable properties? When you see the measurable properties, pressure, temperature, volume, and mass, number of moles or mass. These are the measurable properties of gases. So gaseous pressure we can measure. Pressure we can measure, and gas temperature we can measure, volume you can measure, and as well as mass we can measure it. The gas laws explain the relation among these four measurable properties. The laws which explain the relation among pressure, temperature, volume, and mass is known as gas laws. The first one is Boyle's law. This is scientist Boyle's. This Boyle's law, you have to remember with respect to Boyle's, it is considered as PV law. PV law. Boyle's law, whenever you say, you have to remember PV. He explained the relation between P and V. What are the measurable properties I said? Pressure, volume, temperature, and mass. Temperature and mass. So temperature and mass, these two are constant. These two are constant. Among four measurable properties, this temperature and mass and constant, he explained the relation between pressure and volume. As per the Boyle's, the statement is the volume of given mass of a gas is inversely proportional to its pressure. The volume of given mass of a gas is inversely proportional to its temperature. Here what are constant ma? Mass is constant and temperature is also constant. So at a given temperature, at constant temperature, the volume of gas is inversely proportional to its temperature. Inversely proportional means its pressure, 1 by P. So that's the reason I am saying about this is PV law. This we can represent it in one more way. P is inversely proportional to 1 by V. P is inversely proportional to 1 by V. So V and pressure, volume and pressure both are inversely proportional to each other. When volume increases, pressure decreases. When pressure decreases, volume increases. So this we will see the statement of Boyle's law and formula. Next, explanation, graphical representation, derivation of gas law from ideal gas equation, limitations of Boyle's law, real world applications of Boyle's law. These are the topics we are going to learn in this Boyle's law. Statement, what are the formulas are come under this? Explanation, graphical representation, derivation of gas law, limitations, and real world application. Examples. See one by one. This is about the mathematical expression P is proportional to 1 by V for Boyle's law. And now we are going to say about the statement. At constant temperature, the pressure of a fixed amount of gas is inversely proportional to its volume. A pressure of fixed amount of a gas is inversely proportional to its volume. When you pressurized on any object, its volume will be decreases. This is a mathematical expression. When you see here, P is proportional to 1 by V. P is proportional to 1 by V. Both are inversely proportional to each other. When you remove this proportional symbol, you will get one constant k into 1 by v. So this p and v, when v comes to left hand side, you will get pv is equal to some constant k. So in this way also you have to define it. The product of pressure and volume are equal to some constant k. The product, the multiplication of pressure and volume, this value is equal to some constant. So this is about Boyle's law. This Boyle's law we can represent with respect to density. We have a formula, density is equal to mass by volume. Mass by volume. Now volume is equal to mass by density. Mass by density. So instead of V, mass is fixed. This is constant. Hence, instead of V, you can substitute 1 by D. Instead of V, you can substitute 1 by D. What is the formula? P is proportional to 1 by V. This is the mathematical expression for Boyle's law. Now I am going to substitute instead of V 1 by D. So P is proportional to 1 by V, means instead of V I am substituting 1 by D. So when you go here, this equation we can write in this format. P is directly proportional to D, or D is directly proportional to P. So in this way we are getting two formulas. One is P is proportional to 1 by V, and second formula we are getting P is directly proportional to D with respect to density. So P. In case of two gases, I am going to show you, my dear students. P is proportional to 1 by V. Hence PV is equal to K. In another hand, with respect to density, I am writing the Boyle's law. P is proportional to D. Then P by D is equal to some constant. P by D is equal to some constant K. For example, in case of two gases, P1, V1 is equal to constant K. Then what? P2, V2 also is equal to some constant K. P2, V2 is equal to some constant K. This is initial and this is after. When in the same way, in case of two gases, I am writing P1, D1 is equal to some constant K, and P2 by D2 is equal to some constant K. So based on these two equations, we can write the formula P1 V1 is equal to P2 V2. Based on these two equations, we are going to write it P1 by D1 is equal to P2 by D2. So these are all the formulas represents Boyle's law with the different expressions. What is P1 V1 means? Initial temperature, after temperature, initial pressure and after pressure. What is initial, what is after means? For example, I am taking one cylinder, entire it is having a gas. This gas is closed with one piston. This is closed with one piston. It is closed. Now its initial pressure P1 is equal to, for example, 2 atmospheres. When you pressurized this piston, when you pressurized from external, this piston is moved from here. Now this is called as P2. So before pressurizing, the initial pressure is P1. After pressure applied on the surface, you are getting P2 is this. Now the pressure of this gas is, for example, 4 atmospheres. So in such cases, we can applicable this equation. Initial pressure and initial volume. This entire thing is the first volume. After pressurizing, the volume should be changed. V2 will be changed. So before the condition experiment, at initial condition, after experimental condition. So initial pressure, initial volume, final pressure, final volume. Same way, initial density D1, final density D2, initial pressure P1, final density P2. So what I mean to say here is, just you have to go through the two equation. One is P is proportional to 1 by V, Boyle's law. The second Boyle's law equation is D is proportional to P. So with respect to two gases, this you have to write P1 V1 is equal to P2 V2. When you want to write expression two gases, P1 by D1 is equal to P2 by D2. For comparing the same substance under the two different sets of conditions, PV is equal to K. Hence, P1 V1 is equal to P2 V2. This is about the graphical representation of Boyle's law. When pressure increases, see here 40, 60, 80, 100 and 120. When pressure increases from here to here, pressure is increasing. So at particular this pressure, 120 pressure, the volume is this one. But this pressure, when you see here, for example, this is the pressure. At this pressure is 40. At 40 pressure, the volume is this much. It means when pressure decreases, volume increases. That's the reason P is inversely proportional to 1 by V. Pressure decreases, see here, pressure decreases, volume increases. Pressure decreases, volume increases. When you observe this experiment, this shows the Boyle's law graphical representation. Now, next point. What are the formulas, extra formulas come under this Boyle's law? I am going to show you all the formulas. Number 1. P is proportional to 1 by the first formula. And second formula is PV is equal to K. Third formula, P1 V1 is equal to P2 V2 in case of different conditions. Fourth formula, log P is equal to minus log V plus log K. Fifth formula, Boyle's law, log P is equal to log 1 by V plus log K. And sixth formula, P1 D1 is equal to P2 D2. How this one came? D is proportional to P. These are the 6 formulas will come, Boyle's law. Once again, I am explaining you how these 6 formulas will come. This is as per definition. As per definition, P is inversely proportional to V, hence P is equal to K into V. So this V comes to this side, PV is equal to K. In different conditions, this is P1 V1, P1 V1 is equal to P2 V2. When you apply logarithm to this, log P is equal to, V is going this side, when you apply log, it is changed into minus. So log V plus log K, already K is there here, log K. This V when go right hand side, it is changed into sign minus because it is log. Log P is equal minus log V plus log K. Now log P is equal to log 1 by V plus log K. So here V when comes to right hand side, V is comes to right hand side from this equation, PV is equal to K. This V when comes to right hand side, it is a divider. So log 1 by V. When this log 1 by V only we can write in this way, minus log V. Both are same. So this PV is equal to K. When you apply logarithm, you will get two equations. This is equation number 1. This is equation number 2. Once again, I am showing you PV is equal to K. When you apply log, this is log P. Okay. This log P into log V. Log P is equal to log 1 by V plus log K. This log 1 by V, we can write in this pattern also. Log P is equal to minus log V plus log K. This is the applying of logarithms. While you apply logarithm for PV is equal to K, you will get these two equations. So overall 5 equations you got it. And the sixth one is, this is also based upon definition. Instead of V, what you have to substitute? 1 by D. Instead of V, when you substitute 1 by D, then you will get the equation P is directly proportional to D. So then in case of two different conditions, P1 by D1 is equal to P2 by D2. So these 6 equations you have to remember under the Boyle's law. Okay. Next, how this PV is equal to K is obtained, I am going to show you. Taking logarithm on both sides, log PV is equal to log K. Log P plus log V is equal to log K. Now log P is equal, when you move this right hand side, that is converted into minus log V plus log K. Then log P is equal to minus log V, we can represent without minus in this way, log 1 by V plus log K. So these are the two different equations. This is one and this is one. And now PV is equal to nRT. Constant PV is equal to K. PV is equal to K, that you know very well about that. P into V is equal to K. K means constant. So PV is equal to nRT. When you write here, why I am writing nRT means this is also indicates constant K. This is called as an ideal gas equation. Always the product of pressure and volume are equal to one constant K. That constant, scientific, as per ideal gas equation, that K is equal to nRT. N means number of moles, R means gas constant, T means absolute temperature. Anyhow, what I mean to say here is, this K, when you observe here, N is the number of moles and R is the gas constant, T is the temperature. For example, when you keep amount is fixed, when temperature you raises or decreases, what will happen is, always this constant is depends upon T. This is the most important point you have to remember. The constant K is always depends upon temperature, absolute temperature. When temperature increases, constant also increases. This is the main important points I am going to explain you. So formulas under the Boyle's law, 6 formulas you are going to get it. P is equal to K into 1 by V. PV is equal to K. P1 V1 is equal to P2 V2. And log P is equal to minus log V plus log K. Log P is equal to log 1 by V plus log K. With respect to density, the pressure is directly proportional to the density. In case of two different conditions, we can write the formula P1 D1 is equal to P2 D2. So how these two formulas are derived means, when you go through this derivation part, log PV is equal to log K. When you apply the logarithms, you are going to get the formulas. So always the PV is equal to some constant. Constant means nRT. nRT. This K is always depends upon temperature, absolute temperature. When temperature increases, constant increases. Why specifically I am explaining this constant with respect to temperature? This constant is always depends upon temperature in Boyle's law. How it will be effect, I am going to show through different graphs. So first one, P is equal to K into 1 by the first equation. This is the graphical representation. In IIT, JEE and NEET and CBSE point of view, graphical representations are most important things. Whatever the formulas I am showing you, four important formulas, we can draw the graphical representation. Where the first one is P is equal to some constant K into 1 by V. It is looking like Y is equal to mx. You have studied in your maths how the graphical representation, it is indicates when any equation is in the form, quadratic equation is in the form of Y is equal to mx form, that always indicate a straight line. That straight line should go to the 0. See here, this is the x-axis. In x-axis I have taken 1 by V and y-axis I have taken P. Pressure and 1 by V. This is the graph represents with pressure versus 1 by V. Pressure versus 1 by V. This is 1 by V and this is the pressure. So pressure I have taken in y-axis and 1 by V I have taken in x-axis. When you go through this, it looks like a y is equal to mx. Y means, see here, this is the y, means P. M means here slope. X is 1 by V. Hence, it moves on through the origin straight line. M means slope. The slope means it is a theta, the angle between the straight line and x-axis. Always this you have to indicate like this. From the x-axis, this line is going, this is called as theta or tan theta. So what is our almost all, it is 35 to 45 degrees. When tan 45 is equal to how much? This is the angle. In that way you are going to get it. This indicates slope. Slope means tan theta. Okay. In case of a different temperature, this is the T1 temperature. Tan theta means it is a constant. It is the constant K. This is K. K is equal to tan theta. So this is K. It means, for example, this is K1. Now, entire this angle is theta 2, that is K2 or theta 2. And entire this angle is what? Theta 3 or K3. It means when temperature increases at less temperature, less angle is there. This one, first one. At T2 temperature, when temperature increases, I told you in the first slide, K is always increases with absolute temperature T. When temperature increases, K also increases. K means tan theta angle. So here at T1 temperature, theta is this much. At T2 temperature, theta is this much. At T3 temperature, this is a T3, theta is this much. When the constant K increases, temperature increases. Temperature increases, K increases. This graphical representation shows P is equal to K into 1 by V. P is equal to K into 1 by V. So it look like a Y is equal to mx, where m means slope, slope means K means tan theta. Based on that, T1 is less than T2, T2 is less than T3. This is small temperature, next higher temperature, more and more temperature. Second graphical representation, PV is equal to K. Product of pressure and volume always equal to some constant K. This graph you are going to get it. This is also straight line from y-axis to x-axis. This is PV in left hand side. Product of pressure and volume left hand side. When you take P or V, anyone, the same value will come. The product of PV versus P. When pressure increases, for example, pressure is here. Pressure increases. The product of pressure and volume should be here. Should be here. For example, the pressure is increases here, and then the product of pressure and volume should be here at T2 temperature, and at T3 temperature like that. So it means what is increasing? When you observe here, the PV is increasing. This line indicates the product of pressure and volume. When pressure increases, PV increases. Or volume increases, PV increases. When pressure decreases, PV decreases. So that's the reason this graphical representation shows PV versus P or PV versus V. It is a straight line from left to right. One more, third one, very important one. Two logs. First one is log P versus log V. Log P versus log V. When you write the equation here, log P is equal to minus log V plus log K. Log V value should be minus, hence the straight line moving towards down from top to x-axis towards. So see here, so log P is equal to minus log V plus log K. This looking like a mathematical equation when supposed to similar with y is equal to mx plus c. Here what is y? Log P is the y. And what is m? Minus 1 indicates the m. What is x? Log V is x. What is c? Log K is c. So in this case, the tan theta means what I told you, my dear students, k always indicates slope. The slope should be 135 degrees. See here I have given a slope, always starts from x-axis, ends with like this. So it value should be 135 degrees. And next, what is the log V? Here one point is there. This point indicating slope. So that is the reason I am writing slope here like this. K is equal to slope. The slope is moving down towards because of negative value. So m is equal to minus 1. This is minus 1 slope. Minus 1 means above the 135 degrees. These are the equations show how the log P minus log V plus log K are going to get it. Log PV is equal to log K. Log P plus log V is equal to log K. Log P is equal to minus log V plus log K. So this expression gives the representation of log P versus log V. And final one, fourth graphical representation is log P is equal to log 1 by V plus log K. Yes, same derivation, how the equations are came. Log P is equal to minus log P is equal to log 1 by V plus log K. So here log 1 by V plus log K, the slope is a positive in this case. It increases from, but it will not start from origin because the log value is there, it is in 1 by V, hence it is having some value and it starts from here. This is the point it is starting. Now when you want to measure the slope, we have to measure the slope in this way. This is the graph represent log P versus log 1 by V. Finally, I am showing all together in one place. Better to easily remember. Before that I explain individually, now I am going to show you all the graphical representations of Boyle's law. So based upon my pattern, you have to remember how to remember all these graphical representation means. In the systematic order I have given. So what is the order I have given? I am going to show you. Please look at the board. First, the line is starting from like this pattern. Next line is going like this, right? Next coming down. Again it is raising, and this is the graphs. These are the 5 graphs. This is graph 1. This equation you have to remember it. Why I am giving like this means this is the graph. Simply, this is the graph. First graph. This one. 3 different temperature means simply you have to draw 3. First graph is straight line like this. Second graph, this is what P is equal to K into 1 by V. Next, second graph is a straight line like this. This is PV is equal to constant. PV is equal to constant K. Equation number 1, equation number 2. Only 4 important equations, Boyle's. P is equal to K into 1 by V, PV is equal to K. And third equation, logarithms you have to apply for this. PV is equal to minus log V plus log K. This is minus. PV is equal to minus log V plus log K. And finally, next one is, it is not starting from 0. That is the reason this line is moving down. I have started here. So this is the difference between this graph and this graph. This is starts from origin. This graph is starting from here. So what is that? Log 1 by V plus log K. Finally, why I have given this? This represents the definition. What is that definition? See here. P is inversely proportional to 1 by V. This indicates a Boyle's law. So these are the 5 graphical representation, very important to identify, to express the 5 different equations. Here the 4 different equations are came here. Total 6 equations I have given you. 6 equations I have given you. Among that, one by one again I am writing number 1. Same. P is equal to K into 1 by V. Second one. PV is equal to some constant K. And the third one, just you have to apply the logarithms. Log P is equal to minus log V plus log K. Simple. Fourth equation, log P is equal to 1 by log 1 by V, log 1 by V plus log K. 4 equations, 4 different graphs. And fifth one, what is that means? In 2 different cases, P1 V1 is equal to P2 V2. Sixth formula, P1 by D1 is equal to P2 by D2. So these are the mathematical equations and graphical representations. I'm going to show you the next topic in this Boyle's law. We can also derive the Boyle's law from the ideal gas equation. The formula of ideal gas equation is mentioned here under. What is ideal gas equation? PV is equal to nRT. This is known as ideal gas equation. P means pressure of gas, V means volume of the gas, N means number of moles, R is the universal gas constant, T means absolute temperature. I am going to derive the Boyle's law. Boyle's law what? What is Boyle's law? PV is equal to K. The product of pressure and volume is always equal to the K. Or P, the same equation we can write P is inversely proportional to 1 by V. Or P is equal to some constant K into 1 by V. So this you are going to derive it. Just simply look at the screen. When N is the amount of gas, or moles, R is the ideal gas constant, T is the temperature. Number of moles, constant, temperature. Boyle's law has 2 primary conditions, constant temperature and a fixed amount of gas. What is Boyle's law? What are the conditions? A fixed amount of gas and constant temperature. Among the measurable properties, I told you what are the fixed measurable properties are four: pressure, volume, temperature, and mass. So according to the Boyle's law, these two are constant, right? Temperature and mass. That only here the equation is saying Boyle's law has two primary conditions: constant temperature and a fixed amount of gas. Thus T and N are constant. T and N, T and N are constant. This and this. This is constant, this is constant. The above ideal equation, the right hand side of the equation, all the variables n, r and t, right hand side, here three are there, n, r and t are constants. Yes, constants. The product nRT of these three constant is also constant. So among these three is constant. Instead of this, when you substitute k, PV is equal to remaining all the three n and n is constant, r is constant, t is constant. As per Boyle's law, these two are constant. Mass and temperature, this is the constant r. So hence instead of nRT, I am going to keeping PV is equal to k. PV is equal to k is the Boyle's law. That's all derived. Finally, the equation becomes PV is equal to k, which is nothing but Boyle's equation. In case of two different conditions, P1 V1 is equal to P2 V2. This is about the derivation of Boyle's law from ideal gas equation. Nothing to worry about this. Here what we are doing is nRT is equal to one constant. That's all. Limitations of Boyle's law. What are the limitations for this Boyle's law? The limitations are as follows. Number one, Boyle's law is applicable only to ideal gases. What is ideal gas? The gas which obeys all gas laws. Whatever the gas which obeys all gas laws, such kind of gas is called as ideal gas. So Boyle's law is applicable only to ideal gas but not real gas. Second one, the law fails at high pressure. When you apply high pressure, this law is not applicable. What they said, at high the pressure increases, volume should be decreases. When you give high pressure, sometimes it will show blasting also. That is the reason at high pressure it is not applicable. The product of the pressure and volume does not remain constant at high pressure but show as a slight increases. What they said, the product of pressure and temperature, pressure and PV is equal to constant, they told. So the product of the pressure and volume does not remain constant at high pressure. High pressure it is not applicable. So PV also, K is not applicable. This increase is due to an increase in the volume which is caused by the repulsive force among the molecules. At high pressure, PV is equal to K is not possible. What increases? See here, when pressure increases, the product of pressure and volume, this product should also increases. Why increases means the volume which is caused by the repulsive forces among the molecules. At high pressure, the molecules are too slow to one another. Repulsive forces become dominate as compactness increases. This results in the expansion of the gases. At high pressure, the molecules are too slow to one another. Repulsive forces becomes dominate as the compactness increases. This results in the expansion. So when you pressurize the molecules more and more on them, at particular stage, there is no intermolecular space is available. At that time, again you are pressurizing, they try to expand reversely. That is the reason expansion takes place. So now this Boyle's law, how we can apply in real world situation? There are a numerous applications of Boyle's law. Some can be observed in day-to-day life. A few of them are mentioned below. You will see one by one. Human lungs. Human lungs is depends upon our Boyle's law. Human lungs is compressing and expansion. Compress and expansion. Compress and expansion. What the happening is going to take place in this case? During the inhalation, the cycle of the breathing system, the lungs expand. This expansion is nothing but increase in the volume when which is as per the Boyle's law causes the reduction in the pressure related to the outside. See here, these are the lungs. When you inhale, these lungs should be expanded like this. Expanded. When lungs expanded means this is the surrounding area inside the stomach. For example, this is your stomach. Here the lungs are there. Actually, lungs size is this one. When you inhale the oxygen, O2 is coming inside. These are going to expand it. Expanded into this much size. Expanded into this much size. When size increases, here the volume is decreasing. When pressure increases, here the volume is decreasing. It means what will happen? What is reducing? Thus, the air flow inside the body due to the pressure difference. Boyle's law causes reduction in the pressure. Pressure should be reduced. Again, when lungs expand is the when inhale it, it means when compressed it, the more amount of gas is available in your stomach in this. When expand, less volume you are going to see. When compressed, more volume. When expand, less volume. Compressed, low volume. Expand, low volume. Compressed, more volume. When compressed means small size, you will get outside more volume. When expand, outside you are getting less space. Based on this, outside pressure is increasing and decreasing due to expansion and compression of lungs. When expansion, pressurizing. Pressure increases the outside. When compress, pressure decreases in the outside. Compress, pressure decreases in the outside. More space is available, pressure is decreasing. When expands, compressed. Expanding, compressing. Expanding, compressing. In this way, pressure increases outside the lungs, pressure decreases outside the lungs. When expanding, pressure increases. When compressing, pressure decreases. So this is our day-to-day life. Air flows inside the body due to pressurized difference. By the same analogy, during the exhalation process, the volume decreases, which results in an increase in the pressure relative to the outside and air flow from the body to the outside. Second, one is syringe. Injections you are observed in your daily life. That syringe, how it will works. When the plunger of syringe is pulled outside, there is the creation of vacuum, low pressure region due to increase in the volume. So compared to outside and fluid gets sucked in this syringe. See here, here one piston is there. When you pressurized, the volume will be decreases. When pressure decreases, volume increases. So here it explains V is proportional to 1 by P. When pressure increases, volume decreases. When volume decreases, pressure increases. Third, soda cans. As we all know that when the cap of soda can is opened, the pressurized gas inside the can expands, which results in the decrease in the pressure of the gas. See here, already before that, the soda can, whatever the soft drinks, as we all know that cap of soda can is opened, the pressurized gas inside the can expands, which results in decrease in the pressure of the gas. And as well as hand bicycle pump. When the piston of hand pump is pushed downwards, the air inside the pump compresses. The volume reduces. This reduced volume increases the pressure and the air is pumped into tires. This one. When pressure increases, volume decreases. Volume decreases means it is going outside the pressure. And last one, scuba divers. When you dive into the sea, the scuba divers also getting pressurized. So this is also one of the real life situation application Boyle's law. When a scuba diver dives beneath the water surface due to the hydrostatic pressure on divers, the air inside their lungs contracts. As diver approaches the surface, the air inside their lungs expands since the pressure decreases on the surface of the water. So this is because the scuba divers when dive into the sea, their oxygen cylinder is mixed up with nitrogen gas. Because when you're moving down in sea, the pressure should be increases. Pressure should be increases surrounding water. When dive into the water, whatever the pressure surrounding this person will come and occupy at a time. So then pressure increases. When pressure increases, our breathing, inhaling and exhaling also increases. Such kind of situation, human blood cells will be blocked. That is the reason to control the oxygen supply where such condition oxygen also at high pressure, it increases the blood pressure. That is the reason to mix this oxygen cylinder with nitrogen gas. But here the thing is when moving down pressure increases. So these are examples of our real life situations. And tomorrow we are going to discuss about